1. Hello, good afternoon, and welcome to a new Food4Rhino webinar. Today, we have the pleasure to have with us to our good friend Pablo Garcia Morena. He's the co-founder and CTO of Miracle, developers of Rhino3DMedical and Shiruscat. And Pablo holds two master's degrees, one in industrial engineering, correct me if I'm wrong, and another one in computer science. And today he's going to show us Rhino3DMedical. This is a new plugin for Rhino that allows you to manage medical images, medical data, and convert this into 3D models, into 3D printable models as meshes, and also do some explorations. And he will also cover one recent case study in Brazil. Remember that this is being recorded, this webinar is being recorded. It will be available for you if you miss one part of it right after it finishes on this same link. And also that you can use the live chat on the right panel of your YouTube screen. And there, please feel free to post any questions, comments, because I will collect all the questions, and then at the end of the webinar, we will leave 20 minutes for that. I will pass all the questions to Pablo. I think also Pablo's colleague, Susana, is there. So I think she will be also able to answer you there. Okay, Pablo, so please start. Thank you for being here. And actually, well, I want to say that today is a very special day for us because today we will be announcing the official release of Rhino 7. So take a look later at your email because probably you will receive any news from Bob McNeel announcing the release of Rhino 7. So.
Yeah. Okay, so thank you very much, Carlos. It's very an honor to present here in Food4Rhino webinars. So I'm going to present indeed our software, Rhino3DMedical, that behaves as a plugin for rhinoceros, for rhinoceros 7 and rhinoceros 6. And the main goal of this plugin is to extract 3D CAD models from medical images, be it anatomical models or we will see other kind of objects that can be used with respect to the images. So the intention of this synergy of Rhino3DMedical within Rhino is to have everything in one workspace with respect to medical data. That means that you just plug your CT scan, especially, but also MRI in the form of DICOM, nifti, etc. You segment that, you view, you analyze, you create 3D objects from that. You can also render them, and of course, you can export them to downstream pipelines like 3D printers. So we focus on the quality of these objects to be 3D printable. Okay, so the first step with the software is to segment an image. That means to take a CT scan or an MRI and segment a region of interest out of it, like you see in this image, that we focus on bone tissue for the moment, but we can also segment cardiovascular and soft tissue. And we have a tool set, a relatively evolving tool set for region globing, for manual masking, for exporting and importing masks, like a bit Rhino style for layers. Then we can extract meshes from those segmentation, from those region of interest, and we have them, in Rhino as mesh objects. And this can be edited, prepared. This can be exported to STL or to any kind of format, and they can be rendered and visualized. And then on top of that, our toolset in Rhino3DMedical also allows to design CAD objects on top of these segmented ROIs that you can have from your CTs. For example, now we are working on creating drilling guides that can be used as surgical guides for the patient specific. And we are currently also working on offering cutting guides for osteotomies. And in the roadmap, there's also implants around there. And then we also, you may know that rhinoceros also include Grasshopper. Grasshopper is an API for Python scripting, for visual scripting. So we also offer compatibility with this API inside Rhino, inside Grasshopper, so that the same processes that I showed you before can be used in a batch, in a bulk way, in order to read, process, and segment the entire data set. This allows to also automate workflow and perform repetitive tasks. And be aware that this is like an API that we offer within the plugin. And so this is like a library of block functions that you can use for your project to automate your tasks. But this is very, very like a bespoke. So you have to orient and structure your project out of this API. And then this is in a glance what the software does. So keep in mind that it segments images, CT images. It extracts 3D models out of it. It lets you design objects on top of that. It lets you batch process multiple images and do any kind of automation that you may think about it. And then before I'll show you live the project, I just show you a handful of use cases that we had recently. This one is an example of a tumor on the pelvis that Dr. Suresh Ludwani just used with Rhino3DMedical, and he used in this hospital in India, in Gujarat, to extract this anatomical model and use it in preoperative planning. So before going to the operating room to extract the tumor. This is another project that we had in Mount Sinai Hospital in New York. So here we had a small collaboration where we had a CT scan of a patient that had a fracture in the orbital floor, and this is very tricky to segment. Okay, so here we had to create a bespoke module only to segment the fracture of the eye, because this cavity is very, very thin. Here you can see at left, you see the cavity of the fracture. In this case, the model was prepared by Sebastian Martinelli, who is around here in Lausanne, in Switzerland, where we are based. And then we had recently this case of Dr. Julio Sampaio, who in Brazil, in Bahia, he not only created an anatomical print of a spine, of a column, but he also designed surgical drilling guides to operate this disease that we have here, this degenerative spondylolisthesis at the lumbar level. This was really, really interesting, because he made all the preoperative planning, he used the surgical guides on place, and he had also this team of engineers creating the model, and also he also used a virtual reality to visualize the model real time. So this is a bit the line where hospital with operations in hospitals are heading now with technology. So this blending of CAD software, 3D representations, VR, AR, and all these things are going to do maybe I could say a disruption in healthcare, and we are very happy to participate on it. So now I'm going to show you a bit the software. Just let you know that these are some cases that we have public, but we have many more collaborations ongoing around the world, like in Colombia, in Brazil, South Africa, in the US. And we are very happy to, if you have another idea of collaboration or project, or you want to reach to us and see how we can work together, just drop us a message here in Rhino3DMedical at miracle.com, and also to get to know the software or the product, about buying a license out of us. Also, please come to Rhino3DMedical.com see more details about the software. Okay, so now I'm going to stop sharing this, and I'm going to share Rhino 7. Moment. To share. Yeah. Okay. So I have around 30 minutes. So I'm going to show you a case where I create an anatomical model of a spine. Okay. So when you install Rhino3DMedical, the difference with Rhino is that you will see a toolbar here on top. So you will see open image, image analysis, segmentation, mesh repair, image filters. So this is the same order that I explained to you about how we process images. So here you come to a folder where you have a DICOM dataset, and then you click in any image, any file inside the DICOM dataset. Okay, and then this might take a while if it's very big. But then the idea is that you will see here a DICOM viewer where you see inside the folder where you click the file what images you can have. And here I want to see one of this patient about the spine. And here you can see the metadata that is inside the DICOM dataset. Okay, so now I open the image. And then first step, I will go to image analysis and then navigate through the image. So here I click, hide this. Oops. Yeah, okay, so image analysis. So you will have a very simple navigator to go through the image as a 3D volume. And here you can go to Rhino. I put this here. You can go to Rhino and match, go further your image, okay? And here, this is a spine. I'm going to already set a threshold about because I want to extract the bone inside this image, okay? So what I do is I put the slider over here. And then you see the green region is what I will extract as a 3D object. Next here, if I click surface preview, then I will already have an estimate of the output image. And here you see, in a code of colors, I see connected components. Then I check connectivity, and then here I see the spine. And I see a lot of small particles that I will not extract, because then what I do is I go to segmentation button, and then I go to first element, surface from threshold, close surface, and extract largest region, because I want the largest mesh out of it. And then, okay, so meshes coming from Rhino3DMedical are normally very massive, very big, and irregular. Okay, so this is something that we had to figure out how to work out in Rhino, and so we did pretty well, especially in Rhino 7, that improves the meshing capabilities. Then you will see how it is when dealing with the mesh. But then you see, here you go to panel layers, hide the images, and here you see your mesh that is already there, okay? And then what I do, so here I go to layers and call this spine. So what I want to do is I want to create a drilling guide over a cervical vertebra, okay? So you go to the 1, 2, 3, 4, 5, 6 one. Here I double click, and then all the DICOM images go to the object. Here I lock the spine, so I don't want it to give me any problem. So in segmentation, here I go to mask from threshold, because I want to have a manual mask of my image. And then I'm going to create a bounding box in order to shrink my area of interest, because it is too big right now. And then I will select this, and here over the spinous process. Okay, and now I will, in segmentation, I will extract this smaller area. Okay, this will be much better to handle because normally these meshes are very big. Here, okay, so I go to layers and hide images. Okay, now I hide the big spine. I hide the bounding box, and then I go to, so we saw open image analysis that navigates through the image, segmentation that extracts the 3D model, and then mesh repairs and image filters. They are auxiliary commands that make your life easier. Mesh repair is very good for meshing. So here I want to extract the largest region out of this vertebra because I see a bit of noise out of it. And then here it extracted it. So what I do is I select some of the noise and delete. And then here I have my big image. And then I will call this, I can delete this one. Oops. This one I delete. And then here I have the vertebra. Then here I'm going to have a color just for distinction. Okay. And then what I do is I open images again. So now I want to better go to the vertebra. Okay, so I want to see exactly what is going on inside. So for this one, for this thing, we have this slicing plane on top, and here you will see what it does. Slicing plane is a plane that I can orient in any direction, because the top front right views are always in orthogonal directions. Okay, but what if I want to see another view that is not exactly an orthogonal one? So here I just move this plane, and then if you see, I put it in the center of the vertebra in order to see the pedicles. And then if you hide the vertebra, you see that the slicing plane is giving you in real time, let's say, the intersection of the vertebra with the CT scan. Okay. So this is very, very useful in order to create the drilling guide that I'm going to do. So a drilling guide is a guide that will let you create a screw, a guide for 2 screws going through the pedicles that are these zones. And so this is good, this kind of setting. So what I do is I call C-plane. C-plane will let me set the origin of reference to this plane. C-plane clicking surface, and then I press enter twice. Then I'm going to lock the slicing plane. And then here I directly come and create my screw guide. So I'm going to create a tube, direction constraint none, to have the tube going here. And then here I set a radius for the inner tube, radius for the outer tube, and then I put it over there. Okay, so I have a tube here, and then I place the second tube at the right part, and then I have it around there. Then I show the vertebra, and here you see how you get already the idea, right, of the design of the guide. So you will place the screws over there. So for this, the slicing plane was very, very useful in order to orient myself. And now I can hide the slicing plane. I'm going to put the tubes that I will call guides in another layer. So for this, I come to change layer command, put it here. and then I lock the guides. And here I'm going to make a base for the tube. So what I do is polyline on mesh, this command. I select this mesh, and then I go to shaded mode to see the tubes. And then here I select a curve that will go over the vertebra. And this is on top of the mesh. And here I select close. Now I convert this to curve through polyline with these settings. And then I rebuild this curve. I rebuild this curve to make it smooth, okay? And now I'm going to use this, I'm going back to wireframe mode. And I'm going to use a mesh repair tool that is a brush that will let me extract some mesh faces over this. So I just select here, this. I select an area over this. And here this is selecting like all the mesh in between. So what I do is I put this in a new layer that I call aux mesh. And then I move this to that layer, to aux mesh. And I'm going to hide the vertebra. And then this aux mesh, I explode it. And then this one, I move to base mesh. I put this to the last part. Put it there. And now I can hide the base mesh. And I'm going to put also base curve. I put the base curve also in a layer, to be clean. I hide the base curve. And then all this I can just remove. I just delete. So here I have the base mesh, the base curve, and the vertebra. And now what I do is I lock the vertebra, and I call patch command in Rhino and select the curve and the mesh. And then this will create a smooth base out of it. Now I call offset surface, and I put a distance. I will put a thickness for this base. This base will be with this offset. And then here, if I go to shaded mode, here you see that the base has already formed. No? And I'm going to make a fillet edge in order to have it with radius, say 0.5, in order for it to be, to be smooth, to be nicer. Okay, so here I have the base of the surgical guide that will go on top of the screw. And what I do now is I hide the vertebra and I hide the curve. Now I have this, I unlock the guides, I have the guide. Now I call Boolean split, and I'm going to split the base with the tube. Then I'm going to split the tube with the base. And now I just delete the extra stuff that I had here. Here I had this. Yeah. Okay, yeah. So now we have here, we design a surgical guide for one of the extremes. Here you see the hole for the screw. And now to finalize this, I'm going to show the other side with a different way of doing. So for this way, we use several Rhino tools that were complemented with a small set of tools from Rhino3DMedical. Okay, because that's how we work in order to find this complementarity. So the things that don't work with Rhino, we have to find the way to do them. in Rhino3DMedical. Now I also do a polyline on the mesh. Here I do a nice shape that I will close. And here I go, again, I do curve through polyline, accept, and rebuild to have it smooth with a maximum deviation that is not so far from the original curve. And now I call this command. I'm going to hide the guides. I call command drape. That drape will create a shape over a window and project it on the vertebra. So here I make a window. And then here I have a surface that is smooth. And what I do is I trim it. I trim it with the curve that I made. I press enter and then the object to trim, and okay. And so here I have a surface that is really matches the vertebra, okay. Now here I call offset surface. And then with a distance of 2. This is a bit more complex because you see it has a bigger grid. And here you see this case is a bit more irregular, but it's still a close option. And here I'm going to try to fillet this, though sometimes a fillet are a bit risky with Rhino, but let's try this one. So fillet will make the guide like smoother and more suitable to to fit over the vertebra. Okay, and now I'm going to finish with the same Boolean operation that I showed you before. In this case, to make this base, we didn't need the mesh repair part. Okay, it did it over this side, but not the other. Well, it's okay. Okay, so then now I have the guide here. Now I hide the vertebra. And I call Boolean split. I'm going to split the base with the cylinder. And I'm going to split the cylinder with the base. Center. And then here, I just delete the parts that I don't want. Okay, then here you have the guide. Okay, and now the last part is we have to join these two guides, no? So the one way of doing is you can have any kind of design that you want, but one way is to extract an isocurve of one of the cylinders, and extract another isocurve, one of the other. And then now here I go to OSnap, and I select center and midpoint so that my curves will snap onto centers of circles. So what I do is I come to center of the first one, and then create a curve over there, and then go to the other center and press enter. And then here I call command pipe that will select this rail and make a cylinder that goes over the rail. Here I set radius, let's set 1, end radius 1, and then I set in the midpoint, that is over there. I select another radius 2. Then here I have a bridge. And the last part is a Boolean splitting over there. I select the surface to split and the cutting surface. And then I hide the guides. And then Yes, so here I just delete this part. And so delete this curve. And here I delete also this. Now here I just show the guys again. I hide the vertex. Well, now I'm just, I have to export this to STL, but first let me show, yeah, you can see here how it fits the surgical guide on top of the vertebra. And there's other designs that maybe, that make the bridges a bit more close to the spinous process, or that covers the spinous process directly. Okay. Last step, you select all the parts. I'm going to hide the vertebra, select everything, and then call export selected and select them as stereolithography. SC6 spine with a tolerance of 0.01, and here you press OK. Export anyway. Okay, and then I can, if I open a new session, actually I'm just going to put this in another session with surface. And then put it there. Then I hide surface. And then here, if you import this, you will have the this weld angle. You press OK, and then here you have the final model that you can normally send to the 3D printer. Okay, and that's an example of that I made of going through the whole process. Okay, so I started opening an image with DICOM, then I went to navigate through the image, show the image here, and then I selected a region of interest through a threshold. In segmentation, I went a bit deeper, converting that into mask, running a bounding box over it, and I can still go further and remove details with manual painting tools. Okay, and I could also import or export masks at that extent. And then that was for segmentation. Then I went to extract the model of the vertebra, and then I went with meshing tools in order to actually extract the models. And for that, I use several tools that are in this mesh repair. And image filters would be to apply some Gaussian filters, some smoothing filters over the initial image. Okay. So that was just a glance of all the process. And this was a case on spine, but there's many other applications that we are doing in domains like orthopedics, craniomaxillofacial, and yeah, bone tissue in general, and as well as some soft tissue cases. So I think that I know Carlos, I think it's done for me. So I think it will be a nice opportunity to go into questions, or if some of them want to more know about something.
Excellent, Pablo. Great presentation. We've learned a lot, and I think we are still here because I was doing some jokes with you about the blood, right? That people that
Yeah.
cannot see blood, but there was no blood here. Perfect. No, excellent. And yeah, I mean, we have 140 concurrent viewers from all over the world, as always. People saying hello to like Kyle Babbitt, Karen Michal Lima Salazar, Valeria Palacio, the people from Callisto 3D, Gersh Baderer, Ioana Simenodio, okay, from all over. And yeah, there are a few questions. Let me move this to my screen, otherwise you see my profile and not my face. There is one by the British Orthopedic Research Society, by BORS 2020, I guess this is a nickname, and he's asking if you are able to extract section properties from the plane. For example, area, second moment of area. when you cut with a plane, if you are able to extract those properties.
Through the plugin, no, right now, but I think through Rhino it's possible. It's possible, right? You can at least create a cube.
From a plane, yes, sure, yes.
Yeah.
I mean, you can select a plane in Rhino and then extract the, there are different properties.
Yeah, and or you can create a surface over that area and extract properties from that surface, like the area, as you said, and
yeah, maybe you can show it in your screen if you go to the Analyze menu. Analyze menu, to the menu, just to the menu, one of the top menus, exactly. If you click on Analyze, and there under Mass Properties, we have area centroid, area moments, and then volumes, volume centroid, volume moments, etc.
Yeah, and I think to show the surface. Oops.
Exactly, you will need to select, in that case, I guess, a plane.
Yeah. Oops. If I explode, yeah, normally here in Analyze, I can extract the area.
Exactly.
Yeah, the area is these square millimeters, and
yeah, this depends on the units you have in your model. Of course, this is all customizable.
Yeah. So those that are through Rhino, but if you need a very specific measure that is needed in medical settings, like the Cobb angle. Cobb angle is an angle over in a spine that is very a very long deviation over a column. The Cobb angle measures this deviation, and we can also provide a way of measuring that. Okay, and for that, please get in contact with us, to provide that specific measure.
I hope this answers Boris 2020 question. Otherwise, please post again on the chat. And more questions, in this case by Joe Boguski. He asks if Rhino3DMedical is able to extract airways in the lung.
Airways in the lung.
In the lung.
Yeah.
If you pronounce lung or lung.
Yeah. Yes, so that's hard. We know that some people have done it to extract the airways in the lung, but we don't recommend the use of Rhino3DMedical for that. Okay. We guarantee results for bone tissue, and you can try for lung. So the model that I showed you in the presentation was a full lung, and it had the negative shape of the airways, but we couldn't cement one by one. You know what I mean? So you can have a broad estimate of the airways, but it's hard to cement one particular way. It depends on the resolution of your scan. So I would advise you try it with your scan, and then you will discover. By the way, you have free trial license of the software, so you can just try it.
Yeah, remember you can all download an evaluation version of Rhino3DMedical on food4Rhino, and there on the same food4Rhino page you will find the tech support email address of Miracoy, so you can always contact Pablo privately. What else? Ombro Cotovelo thanks you, and he says he learned a lot how to create more anatomical guides. Also, Mike McCann thanks you. He says this is really powerful. Thanks also by Biomedicine, by Gers Baderer, Sanerix. Well, Sanerix makes, yeah, it sounds like mostly Spain. I agree with you. Both Pablo and me are Spanish, and we have this same accent. It's very hard accent. No, it's difficult for us to pronounce English like UK guy or American guy. But I hope you understand us. And congratulations from Florence, from Simone Tanini. Italian is easier for us than English. And yeah, Valeria Palacio says, thanks, Pablo. I have a question. The command drape is a new tool from 3DMedical or is directly from Rhino 7?
No, that one is from Rhino, and it's from Rhino. It's in Rhino 6 also.
I think it existed even before, probably since Rhino 1, but I don't remember that all. From Rhino 2 for sure.
Yeah.
Yeah. I mean, probably it has been improved during their years, but basically it's a Rhino function.
Yeah, and it's just that it's a bit, as you see here, the drape shape is too complex, too dense, and that's something that the guys of McNeel could work out a bit, how to improve. But it's very, very helpful function to this extent.
I mean, for much more advanced drape functionality, you could give a try to Kangaroo. Kangaroo is a physics engine included in Grasshopper. It's another story, but there you can really simulate like a drape with much more precision. What else? Ha estado muy bien, so it's very nice, from Servicio Radiodiagnóstico CHT, probably you know them. Claudia Davila also says many thanks. El Ansari Yassin asks if we can take dimensions from the scan. Manually, I guess so, right?
Yeah. I mean, show when you have the scan. Let me show you here. Well, first in the DICOM metadata should tell you if the dimension. And then if you go to you can call RM image info. That will tell you the voxel spacing. So so normally the mutation. Yeah, here pixel spacing 0.675, 0.675, and from there in image analysis, you have the number of pixels that you have, and then you can also just measure in Rhino. How you call it when you measure a line?
Length or length. Distance? Distances between points.
Yeah,
would be length.
So you, for example, you create a line from this center to that center, and then from here to here, and length to measure it. So 344.365 millimeters for this, and of course it must be higher the dimensions. But that's a way for you to know through the metadata of your DICOM data set and manually through Rhino measuring functions.
Right. More questions by Eli Suarez this time. When the TAC is bad, are there tools to improve the mesh surface?
When
the TAC, I guess the CT images, if it's bad quality, if there are tools to improve the mesh surface, I guess yes. From a bad image, you create and not the optimum mesh surface. So if there are ways to improve the quality of the mesh surface.
Yes, so here I have a quick example of a phase where you go to image filters, and you can go to a smoothing filter where you can like increase the strength of this filter. No? This is too strong, but you could go to median filter, for example, to here to make the image a bit smoother. Maybe it's a bit difficult for you to see, but if you click on preview, it removes a bit of the noise of the image, so that when you segment it, you segment it, it gives you a smoother mesh. Okay. So this mesh has been smooth, and you see, for example, that the teeth are a bit blurred, you know, and it's a way of removing some noise of your image. This is very quick case. No?
Nice.
Then apart from that, you can manually remove some noise, and then extract the biggest part. Okay, the part that you want, and then remove all that you don't want. So yes, there's these manual editing tools and filtering over the image to make it better.
Great. More questions. This one is more about the algorithm you use to create the mesh. Lord Pompillordo asks if you can share any details about the mesh process. That is, if you are converting the image to voxels and then smoothing the surface of a collection of voxels.
Yeah. The algorithm is the state of the art in in extracting meshes from voxels. It's called the Hope algorithm, where you have the set of voxels and you create a mesh over it, and it's called the Hope algorithm. I can't.
Okay. And it's public.
Yeah.
Algorithm. So maybe it's on your website for people that want to learn more about how the meshes are created, or is there a link there? Well, if not, maybe you can add it to the frequently asked questions so that people know.
Yeah, we can add it.
Cool. Related to this, Isaac Watso says, okay, great software. Does it work volumetrically through voxels, similar to Grasshopper plugins like Dendro or Axolotl?
Can you repeat the software?
Yeah, if it does work volumetrically through voxels, like Grasshopper plugins, Dendro and Axolotl. I think he's asking if later what you have are voxels and you can work directly with voxels. I think that's only part of the conversion to meshes, but later you are not working with voxels, right?
No, but this is linking to the previous question. Actually, it works through voxels.
But you can work with these voxels later as well, because Rhino doesn't support voxels.
No.
I think that's a question.
Yeah, I should see how these Grasshopper plugins work. But if there's a way to make compatible this voxelization over these plugins, then it should be possible.
To join forces.
Because what you see here in the end is a matrix of voxels, and then a way of converting them into meshes. Yeah, but here, so I would say like the big improvement here is how to put together all those things, no? Because it's how to read the DICOM data, make this voxelization representation, and convert it into a Rhino or a mesh object that can be rather exported in a later stage. That's where this combination of tools gives this value.
Nice.
And then all the filterization.
We also have a long-term project to support voxels in Rhino, but it is very long-term. So I don't know if it will be for Rhino 8, Rhino 9, or let's see. What else? Servicio Radiodiagnóstico CHT, they ask, what kind of material are you using to print these guides? I guess it needs to be approved by the medical authority, or...
Yeah. So we have print anatomical prints with different kind of resin, and for the surgical guys we have not print yet. That was up to Dr. Julio, and I guess also some kind of resin. Yeah, that it has to be approved. Sure.
Right. Titanium is too expensive for for just using that as a guide, I guess. No, but it would
Well,
be easily approved. But
no, but for cutting guides, it should be titanium. Yeah.
For cutting, yeah, but
and for drilling.
For drilling, probably. No.
Yeah.
Well, I'm not an expert in the field, so.
Yeah, I mean, yeah. I mean, what I say here, yeah, I don't.
No, I mean for the guides that later you are throwing away that are just supports. Probably you are using another kind of material that is more affordable, right?
Yeah. Only for preoperative planning, you can print for sure in resin, in FDM. Then for operation, that's different. And yep. there I still cannot claim anything on that part.
Okay.
Yeah.
Questions for ombrocoetohuelo. Pablo, to extract bone in an article, for example, how to extract each vertebra or femur from acetabulum?
To extract
a bone in an article. I think articulation, maybe?
Articulation.
Probably.
Yeah, yes. So
how to extract each vertebra?
Yes, so you should go what I show of the segmentation. You should go manually, to extract. For example, you would start with a bounding box, like here. And here I double click. Then here, make it as accurate as possible. Let's see if it's just a quick example. Show you, and then if you still have more like things that you don't want, you should go manually over the paint tool here
and do the booleans or the cuttings manually, right?
Yeah. So here in paint, you would, for example,
paint only one area and then.
Yeah, you paint one area. For example, imagine you want to cut this part, and then you navigate a bit in this direction. Then you draw another one, press enter, and then you interpolate in between with this fill between slices, so that you don't have to go slice by slice. Okay.
Really cool.
And then finally you remove from us. You apply, and then I have removed this area that I saw. So these are in a very toy case, but in your vertebra, you should go a bit, you should enclose the vertebra and spend some time over it. So first, initial approximation with a box, and then remove detail with the paint tool.
Mm-hmm. Very nice. More by Huntergal. Can you import image data in RAW format?
In RAW format?
RAW format, yes. RAW. Yeah. But
so what I know is that I can open MHD. So for example, when I open this head in MHD, it has a RAW format next to it. So you should have an MHD associated with your image, and then we can open that. And then DICOM, metadata, any kind of things.
Mm-hmm.
Yeah.
Okay.
So nifti, DICOM, metadata, and NERD. And those are
all specified. All the file formats you support are specified.
Yeah, they are specified. Right? Yeah.
Perfect. Daniel Rodrigo Morales says, I guess this software has more applications on bones than on soft tissue.
Yeah, absolutely. Because of our plan is to first do things well in bone tissue, and do these things of segmentation, filtering, and mesh extraction, and then at some point develop them for soft tissue that are trickier. But it's possible to do some initial things with soft tissue, like the lung extraction that I showed you before.
Mm-hmm.
Some very like very broad representations, like the heart or the lung.
Nice. Okay. In the middle of the questions, many people are again thanking you for your great presentation, like Harshit Gupta, Joe Boguski, etc. Sanerix asks if these functions are available only in Rhino3Medical or also in Rhino3D. Well, it depends. Most of the functions Pablo showed are from Rhino3DMedical. Some other, like creating a bounding box, doing the Boolean difference, doing the measurement, etc., are Rhino inbuilt functions. Carlos Benito asks if there is some automatic segmentation tools. If there are automatic segmentation tools.
Yes, so automatic. It depends a lot on the project, no? So if the more information you have about what you want to automate, the better. Because what we offer is an API to automate your process. But what we don't offer is just like I would say like a neural network giving you segmentation. What we offer is a scripting library that you can use in your data to automate tasks, very specific tasks. This is what Grasshopper does, no? The scripting.
Sure.
So you can automate tasks through programming your scripting, your project with it. And for Grasshopper, I didn't show anything, but in the website you find tutorials and documentation on how that works.
We can organize a second webinar in a couple of months, and then you can maybe show some nice applications with Grasshopper.
Yeah, I didn't show it because that's really more
related to next question, probably, maybe. Jose Alberto Blanco Fernandez asks, he has two questions. How many files, how many models can you segment at the same time? And how could you automate the segmentation? I guess you could use Grasshopper for that.
Yeah.
And how many models at the same time? Depend. I don't know if he wants to do a batch segmentation or.
Yeah. We have a collaboration in the US where there's somebody using it for 300 cases at the same time, I think. So it depends on the capabilities of your PC in the end.
Okay.
And Grasshopper. So I don't know exactly how the capabilities of Grasshopper, but they are pretty high. In the end, it's a Python interface. So it depends also to how Python is up to the task.
It should. I mean, we have GH Python and it should be compatible. Now, Mauricio Morinigo. Hello, Pablo. How are you? First, congratulations. Excellent presentation. Could you design this pedicle-based transverse process to serve as a support and for the structure to be stuck? If you want, I can repeat the question.
Yeah. I mean, he's asking if you can use this in, like for preoperative planning, no, for example.
I think so.
Yeah.
As a support.
Yeah. You can absolutely print it, and it will fit on the vertebra. Yeah. And be careful when you print it to put the support like over the part that is not touching the vertebra, so that there's nothing to polish.
There, I guess. Well, of course, a doctor is needed. No, it's.
Yeah, absolutely.
Biomedicine now. Hey, Pablo, cool workflow. In order to fit the surface of the guide onto the bone, need to ensure adequate soft tissue clearance. Is there any way to estimate that? So in order to fit the surface of the guide onto the bone, he needs to ensure adequate soft tissue clearance. If there is any way to estimate that.
So the only way is through the CT. So
to the CT. Maybe some collision detection there.
Yeah. So you should go over the same way I'm showing you a CT. So you should go over your your mesh model. So here, for example, I show this is the intersection of the mesh with the model, and you should really go over every slice of the CT and go and check that there's no soft tissue that is really exceptional over the mesh. But this is normally something very important that the doctors clean a bit before operating, clean a bit the spinous process.
Perfect. Many thanks for all your answers. You know everything. Sorry if I'm going to go very fast now, but we are running out of time, but well, we can exceed it 5 minutes, no problem. Matex Balaban says, if it's possible to make better resolution model with more scan, can you fuse the scans?
You mean well, to merge two scans?
I mean, if you have more scan data, or more images, if you can make better resolution model, I think, yes, it's obvious that if the better the images are, no?
Yeah, but maybe
the better the model will be.
Maybe he asked about merging different scans.
Yeah, that's also a question, yes. If you can fuse the scans.
Yes, so that's not possible.
Not possible.
So the workflow is with one scan at the time. But please let me know about your specific project or question, and we can figure out how to merge different scans or offer some a comment working with different scans, how to multiply different
scans into one single model. I guess that was the question.
Yeah. If they are correlated, it's very easy to just sum it. More difficult is to register one against the other.
Okay. Eli Suarez now, he's asking if you have FDA approval, I guess.
No, so this is an important question. So we are not certified right now under the EU regulation, but we are looking very much to certify the software during next year or very close to it. Yeah, we are now looking into the regulations.
Okay.
So answer is yeah.
And she also asks if the trial version is free.
Yeah. Trial version is free for 45 days. And then just get in contact with us if you need more time, or if you
can extend
more
it.
licenses, yeah.
Perfect.
There's absolutely no issue.
Then is it compatible with the new Rhino SAPD?
Well, I mean,
I guess anything you model in Rhino can be converted into a SAPD, right?
Yeah. But in terms of API, I still didn't look at the API of SAPD, but I'm sure there will be something useful for to work with.
Perfect. And also, if it's compatible with Rhino 6, yes, it works both on Rhino 6 and 7, right? Now, okay, from Matej Balaban, will it be possible to use this also as a diagnosis tool with showing just the deviation from standard healthy shapes? So if it will be possible to use this as a diagnosis tool with showing just the deviation from standard healthy shapes?
Well, the software itself will not be intended for diagnosis. It will be intended for, we have to still clarify that, for preoperative planning, for anatomical prints, for complementary information, to have the 3D model, and it's up to the doctor to make the diagnosis. But the software will not say diagnosis. But I guess what he meant is that if he can measure the deviation, with respect to a healthy model. So for that, we should look a bit more into details how to measure that deviation. Okay. Right now, there's not such a function, but it's a bit related to the measurements. If you tell me the measurement, how to make it, then we can make that functionality.
Nice. And there are only a few questions left. One is by Joanna Simeonidou. I can never pronounce your name, Joanna. Sorry. You show two processes, fix mesh plus patch versus drape. Which one is preferable, considering we can adjust the density of isocorps in both? Which process is being more geometrically precise to the mesh?
So the first process is absolutely better.
The first one, fix mesh plus patch.
Yes, mesh and patch. Because it's say, it's not as heavy as a drape, but sometimes it doesn't work. So as you say, sometimes in Rhino with patch and filleting, it's a bit, sometimes you see a weird thing happening, and it's hard to make. That's why I show the two options, because the second option normally always works. The first one, sometimes it's hard to manage. Okay, but go for the first one always. Then the drape should be the second one.
Nice. Is it possible to manipulate images before masking, contrast, brightness?
Yeah.
Do you do it directly in Rhino3DMedical?
Yeah. In the navigation that I show you, there's some more sliders for contrast, for brightness, and
Susanna always already answered this user. I see it now. And okay, one of the last questions. Are there ways to have a robotic arm analyze your model for robotic surgery?
Is there a way for a robot to analyze the
First analyze it, and then, well, probably to train him for robotic surgery?
Well, it's about the details. You should tell me exactly how do I need to give you the information to your robot to train him in order to fill the workflow, no? So if it's, for example, if it's the STL file of the mesh, then it's enough. You can just take it. But if it's another thing like the voxelization, then we should just work out how to make that.
Nice. And the very last question by Fukan Yang. Let me check if I can pronounce this medical. Well, the first one is not so difficult. Okay. Is it possible to segment soft tissues in brain like gray matter or cerebrospinal fluid from MR images?
Yeah, so I think it will be, it's possible to segment like the whole brain. It's a bit harder to get into the brain and segment specific parts. Also, we don't have much experience with that, but I recommend that you try it, that you open your MRI and see what can be done. So maybe it's possible. I have not tried so many MRI.
We recommend Fukan Yang from here to download the evaluation version, give it a try, and contact Pablo in case you need more details, right?
Yeah.
And the very last comment by Servicio Radiodiagnóstico again, for when the next session, it was wonderful. Well, I think when Pablo tells me he has new stuff to show, we'll be glad to organize a new webinar.
Yes, so what I show you, for example, the surgical guides, this process could be automatized, for example, with Grasshopper, and that's a bit like a big goal, no, for it. And I will be happy to make a session with Grasshopper, for example, to make this realized. When you have one of these cases of scoliosis or a lot of vertebrae to be fixed, you have to create these guides for a lot of vertebrae. So you can have like 10 guides, in one column. So that's a very, important problem that there's right now.
Wow. Maybe we can also organize a live surgery here.
Yeah, of course.
Okay, Pablo, it was a pleasure. Many thanks. And hope you are doing well in Lausanne. Probably you miss Barcelona for the weather, right? But there you have the mountains, you can go skiing.
Yeah,
And yeah, for the audience, remember this is being recorded. The video will be available on this same link, on this same page right after it finishes, in case you missed one part. And hope to see you soon with a new food4Rhino webinar. Have a nice day. And as mentioned in the beginning, today we are officially announcing Rhino 7. So you can go now to the Rhino website and download the evaluation version or order your upgrade already. Thank you. Bye.
Thank you very much, Carlos. See you.
Bye-bye.
Bye-bye. See you.